Hello everyone, I'm Frank and welcome to Frank Puzzles. And this is a very hard puzzle, which is not a normal Sudoku. So this is not essentially the normal Sudoku puzzle that I normally do. This is going to be an extra for... I just wanted to do this puzzle essentially because it seems interesting. But it doesn't have anything to do with Sudoku. So keep that in mind. This is going to be very hard too because we don't have any intuitions that we have derived from solving a lot of Sudoku puzzles, so this might take a long time. Anyways, this puzzle is called Summon by K and I. And here are the rules. We have to place the numbers from 1 to 4 in each room exactly once, such that no number touches itself, even diagonally. So what is a room? It's basically a designated region which is filled with cells, right? So this is considered a room up here. This is also considered a room here. And we have to have the numbers 1 through 4 exactly once in each room. So that means 4 cells are going to be filled with digits 1 through 4 once each, and the rest of the cells are blank. And that leads to the other rule, which is connected blocks of numbers in a row or column form numbers by reading left to right or top or downwards, basically top to bottom. Clues outside the grid are equal to the sum of all such numbers within the corresponding row or column. So, for example, say we had something like 312 here. This would count as 312, which means that along with the other numbers in this row, you would have to add up to 527. So we could have something like, I don't know, how does that work? So maybe we have a 1 here, and we have 2, 1, 1, and 4 here. So 1 plus 312 is 313, plus 214 is 527. So this would satisfy this sum, right? Because we read it from right to left. So it's 214. This is 312. And the spaces means that these are separate numbers here, adding up to the sum designated outside the grid. And those are all the rules. If you like to play along, and again, remember, you can only have the digits 1 through 4 once each in every room, which is every designated region here. So, yeah, and this satisfies that perfectly, right? You could have a 1, 4 here. This is 2, and you have to have exactly 1 of each digit from 1 through 4 in every room. So that satisfies that here. These are 1 and 4. That's 2. This is 2, 1, 3. So you could have something like, say, a 4 here or something along those lines, which would basically satisfy that room having the digits 1 through 4. Anyways, those are all the rules. I don't know how long this is going to take. You guys will probably... Well, you'll know that I'll have spent a certain amount of time at least with it. I could have another video related to this. Which I'm probably going to be getting stuck here because I don't have any intuitions about this type of puzzle at all. I just thought it was a very interesting, it's an interesting rule set, and I'm curious where it's going to lead. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, the first thing I see is We have 1106, which is what these must sum up to. We have two regions here, which both have 5 cells total in it. And remember, we have to place the digits 1 through 4 exactly once in every room. So if we had all 4 digits in this row, the problem is the minimum for that number would be 1234, which is bigger than the sum of the digits, the numbers, sorry, in that row. So this cannot have all 4 digits being here. If it did, that would not work. And it's the same thing with this. This can't have all 4 digits being here. So we know we have to have a digit here. So we're going to mark it as green. We have to have a digit here. And the thing is, say we didn't have a digit here. You could have a set of 3 and then a set of 3. That could work. That's another thing. To add up to 1100, how many sets of 3 digits can you have? You can't have a set of 4 digits because 4 digits adds up is a minimum of 1234, which is too large. So it has to be at least 2 sets of 3-digit numbers, and it has to be 3 specifically. Because if we had 2, the maximum would be 432 times 2, which is 864, which is still too small. We need another 3-digit number there. How many cells do we have? We have 12 in total. Okay. So 12 in total. That means there have to be 2 spaces between at least the 3-digit numbers. But the interesting thing is, so how many of these spaces can be numbers? So we could have 1, 2, 3 space 1, 2, 3 space 1, 2 space 1. Okay. So the question is, what happens for all? We can't have 400 plus 400 plus 400 because that leads to 1200. So one of them has to be at least 3. You could have, I guess you could have. So again, we could have 3 digits that are in the hundredths place. Oh wait, hold up. 1, 2, 3. Okay, so we can't have. Okay, if we try to have 1, 2, 3, 1, 2, 3, 1, 2, and 1, that doesn't work because we have 432 times 2 at most, plus, so that would be 864 plus a maximum of 43, which would give us 900 and something, plus a single digit of 4, which would give us, again, 900 something. So that's not possible. You have to have 3 sets of 3 digits, adding up to 1106. So that would be 3 space 3 space 3. So it has to be 3 space 3 space 3. It has to be 3 unique digits. 3 unique, not unique numbers. 3 numbers, each of which are hundreds, basically 3 digits combined to add up to 1106. So the possible combinations, you can't have 3, 4, and 4. You obviously can't have 4, 4, 4 in the hundredths place because that adds up to 1200. You can't have 3, 4, and 4 because that adds up to 1100, but we have to have tens digits, which are greater than 0. So the tens digits must also add up to at least. So we have, okay, how many carries do we have? The ones digits, you can only have a carry of 1. So that means the tens digits must add up to either 9 or 10. It's the same thing with a carry of 1, and you have to have a carry of 1 for the hundreds digits. Because if you don't have the carry for 1 in the hundreds digit, then the tens digits can never add up. And tens digit can never add up to 0. Tens digits always have to add up then to 10 or 9, which means it's going to be a carry. 6, you can never get to 16. So 6 is never going to be carried on the ones. So you have 3 digits adding up to 6 in the ones digit. So it's 1, 2, or 3. That means the tens digits must add up to 10, which means there's a carry of 1 over for the hundreds, which means that those digits must also add up to 10. So we have 10 digits adding up to 3 digits adding up to 10 in the hundreds place, 3 digits adding up to 10 in the tens place, and 3 digits adding up to 6 in the ones place. So that's 26. Is that right? 10 plus 10 plus 6 is 26. We have a possible fourth digit here, which could be right. Okay, so technically, actually, you could have added to 16, but that would require all the 4s available in row 1, which means that you would have at minimum for the hundreds digit 3, 3, and the maximum for the hundreds digits as 3, 3, and 3, because we don't have 4s anymore available in the 4 regions here. Which would mean it would add up to 9, which we can't have, again, for 4 sets. Actually, we don't even have 4 sets, it's 3 sets. Never mind, you can't even have that. You have 3 digits. If you have 4, 4, and 4, that adds up to 12 at most. So that's never going to add up to 16. So it always adds up to 6 for the ones digit. It always adds up to 10 for the tens digit. And it always adds up to 10 for the hundreds digits. So that's 10 plus 10 plus 6. Say we had 4, 3, and I guess that works. 4, 3, 1, 4, 3, 2, 4, 3, 2. Yeah, you could have. So this has to be 3 continuous cells. Because if we try to have this as broken up, so 2 and 1 here, say we had 3 here, 2 here, I don't know, another 3 here, and then you have, the problem is you have a 1. So that doesn't work. So these are guaranteed then to be, you can't have this set broken up. So it's either 3 here or 3 here. What about... You can't have this broken up either, right? So if you break up 2 and 1, or 2 and 1, this obviously doesn't work because you could have 3, 2 and 1, and then another 3, but that doesn't add up to 1106. If you try to have... Yeah, this just doesn't work. If you have 1 and 3 here, then this is 2 at most here. So you can't have 3 unique digits, sorry, 3-digit numbers adding up to 1100 there. So these two also must be green. This could be 3. Okay, so these two also has to be green, right? So if this is green, you could have green, green, and green there. Or green, green, and green here, or green, green, and green here. But these have to be green. Okay. We have a 2-digit number here. It must add up to 30. So this cannot be another digit because that would be too large. This is kind of similar. So because of this, this can't be 3 sets of green adding up to 527. But we don't need 3 cells. We have to have 2 at least. Well, could we have 1? Probably not. If we have a singleton 3-digit number in this row, this can't be 3 here. This has to be 1 or 2. Let's see. You cannot have all 4 digits being here, adding up to being a number, because that would be, again, 1,234 at minimum. You can't even have 3 digits here being the same number, but you could have like a 2 and 1 combination here, and that could work. Huh. So this is 1 or 2. You could technically have 200 and something. So that does... Can it ever be 1? I don't think so. So to add up to 10 for 2... This is either the tens digit or the hundreds digit. So they both must add up to 10. And I think the thing is, it has to be 2. 1 at maximum adds up with 4 and 4, which only adds up to 9, which is not possible. So this has to be 2. So this is 2, 20-something. Either way, as a tens digit, as a hundreds digit, it must add up to 10. So the other ones must add up to 4. But we don't know if it's the hundreds or it's the tens, and we don't know which one is the tens and the hundreds. Okay. So that means these must be singletons here to add up to 30. And it's, well, we don't know. We don't know how many. It could be 3, 4, 3. It could be 1, 2, 3, 4. It could be 1, 2, 2, 1, some combination there. So we don't know about that one. We have 527 here. At least one 3-digit number. How many 2-digit numbers can work? So say we have 3-digit, 2-digit, space, 2-digit, space. So that could very well work. Right. Yeah, that could very well work. Or we have multiple 3-digit numbers. Interesting. So this would have to be 4, obviously. It'd have to be 400 something, because the remaining 2-digit numbers, essentially, can't ever add up to 200, right? You have 40 something at most for each of the sets. That's times 4 is 160. So you only have that amount. That is possible, though. And you can always have 2 3-digit numbers, so that also works too. So that's not that restrictive, unfortunately. Hmm. What else do we have? So this has to be 1, 3, and 4 here. Again, this could be something like 434. Oh, I forgot to... I forgot to say that no number can touch itself, even diagonally. That's actually very important. Ooh, okay. I'll put that in the rule in the nota bene. I forgot about that. Apologies for that. That's going to be very important. So 2 cannot be either of these digits here. Um, hmm. Okay. Hmm. This digit cannot be any of these digits here because it would be touching itself diagonally. So it must be one of those 2. Is that helpful? I don't really know. Oh, this digit cannot be any of these. Apologies, I have a phone call. I'm gonna do that. And I'm back. Okay, let's continue with this. Right, so this digit here cannot be any of these digits here, so it has to be one of these 2. Huh. Oh, that's going to be interesting. So one thing we know is it can't be 3, 2. One thing then, if we try to do something like this, 3, 2, 2, and 2. That's not going to work. This digit cannot be any of these digits here. Can't be here. It would have to be here, and this would be a 3-digit number adding up to, obviously, greater than 37. You could have something like this, though. Or I guess you could have... You don't have to have the 3-digit number here. So say you had 2 digits, 2 digits. You can't have 3 digits there either. Hmm. So that's going to be problematic. I think then that almost guarantees it has to be 2 3-digit numbers, right? If you try to have 3 plus 2 plus 2, I guess this could be 3. 3 plus 2, that could work. That could work. Can you ever have it without 4 2-digit number, without 1 3-digit number and 3 2-digit numbers is the question, right? Can you have a singleton ever add up to 527? You'd have the tens add up to 12. The singletons could not add up to 17, so they would have to add up to 7. Sorry, the ones digit would have to add up to 7. The tens digit would then have to add up to at least to 12. But you would know that this tens digit... So we're trying to do it without 3 doubletons here. 2-digit numbers here. So again, the ones digits can never add up to 17 because you have 4 at most there. So it's 16 at most. So it has to add up to 7. Therefore, the tens digits must add up to 12. And it would have to be 4, 4, and 4. But then the hundreds digit here could not be a 4 because you would have two. You'd have a 4 here and then a 4 here, right? So the tens digits would all have to be 4s, but then the 100 digit for the 3-digit number has to be 4 also, which would mean that the 4s would be touching each other, which is not possible. So it cannot be a 3-digit number and then a 1-digit number and two 2-digit numbers. It has to be a 3-digit number with three 2-digit numbers, or you could have some combination of two 3-digit numbers with some other digit, with some other things there, right? Um, hmm. Okay. Hmm. Um, does that tell us anything? I'm not sure. For this 2, we know that the other digits have to be 4 and 4 to add up to 10. Um, Therefore, the other set of 10 have to be 3, 3, and 4. Because basically this if this is the hundreds digit, that means the tens digit cannot contain two 4s. So the most you could have is 3, 3, and 4, which have to be. And if this is the tens digit, the hundreds digits cannot have 2, 4, and 4. So that means it has to be 3, 3, and 4. Okay. That means we have all the 4s accounted for in the hundreds and tens digit. Right? Because we have three 4s available. Oh, that's not true. We could have a fourth 4. Okay. We could have a fourth 4 being here, right? And that would be a ones digit, so that could work. You could have 4, 1, and 1. So you have 2, 4, and 4 adding up to 10. You have 3, 3, and 4 adding up to 10. Well, okay, so what happens if it's 3 here, and then 3 in some sort of set here, and then 3 in some sort of set here? Let's ask that. You would guarantee have 4 and 4, which would make that 3 and 3, and this 4, if that's some combination. Then these digits would have to add up to 10. Or, sorry, 6. Right, so we have 3, 3, 4 adding up to 10. 4, 4, and 2 adding up to 10. That gives us the 1,100. This would have to be 1 or 3. And this would be 1 or 2. I guess that could work. 1, 2, 1, 2. Huh. So this would be a space, obviously. You'd have space here, space here, space here. So that's fine. This would be 1 or 2. This would be 1 or 3. So we'd have to have a 3 here. So this would be 3. This would be 1. Because you have to have 1 and 2 adding up with 3 to add up to 1106. If you had 1 here, this would be 2 and 2 at most. So this would be 1 or 2 here. This would be empty. This digit could not be any of these cells, so it'd have to be one of these two. That's fine. Huh. This is 4, so it cannot be 40 something. So say we had a blue there. So actually, you could just make this assumption saying that this digit was green. Okay. We have a problem. This cannot be 3 unique digits there. If this is 3 unique digits, it's going to be greater than 16, right? As a 3-digit number. So it has to be 2 at most. And therefore, we have to have 2 digits here, if that's the case. But then this would be a 3-digit number, which is greater than 87. So this cannot be the digit. Therefore, we know, so that if this is a digit, that forces this situation here. And the problem is if this is the digit, this can't be any of the digits because it would be 4 guaranteed. Interesting. Yeah, so that would be 4 guaranteed, so this could not be a digit here. Therefore, and if we try to have 3 digits here, you'd have a 3-digit number, which is greater than 16, and therefore you have to have 2 digits here, but that makes a 3-digit number there so for that situation. So that does not work, which means we know this is the other digit. So this is 200 and something. So this must be a 4 here, because it must be 4, 3, and 3 adding up in the tens digit. So this is not a digit here. So this is 240 something. This is 1 or 3. All of these digits see this digit here. So this cannot be a digit at all. You can't have a 4-digit number here. It has to be 1 with 2. So this cannot be, this has to be a digit because we can't have all 4 of these be digits. We have to have a 1 somewhere as the singleton digit. So this cannot be 1. It's 2, 3, or 4. This is 1, 3 as a pair. This is a 4 there. What is this? So we have to have 3 digits here. It must be a combination of... So say we had a 2 here. Then this would add up to, guaranteed, 1 in the tens digit, and then 3, 4 in the ones digit, which adds up to 17, which is too large. So this cannot be 2. We could have... this can't be 2 here. You could have 12 and 3 and then 1 somewhere here. So one of these two is a blue. Therefore, we are guaranteed this is a green. This is a green also. And it's either 1 something or 1 something. We don't know. Okay. So, we know this has to be 4 or 3. And this must be 4 or 3. This digit... So again, 2, 4, and 4 add up to 10. And 4, 3, and 3 add up to 10. And this must be... So that means we are guaranteed 2, 4, 4. So 4 has to be one of these two. 4 has to be one of these two. Either this is a 3-digit number adding up to 4, or this is a 3-digit number adding up to 4. So that's 3-digit, or that's 3-digit. And 3 has to be one of these two, and 3 has to be one of these two. That's interesting. Huh. That means in the rest of this box, you cannot have 3 or 4. Huh. Right, because you have to have 2, 4, and 4 adding up to 10, 4, 3, and 3 adding up to 10. And this is either a hundredth digit or tens digit. This is a hundred digit or tens digit. This could be the ones digit or tens digit, and ones digit or tens digit there. Obviously this can't be 2. It's 1, 3, or 4. Huh. So this digit must be one of these two digits here. Okay. We know that this cannot be a digit because then we know one of these is a two-digit number. One of them is a one-digit number. Because you can't have two-digit numbers adding up to 16. So this is not a digit here. This digit sees all of these cells here. So it could be one of these. It has to be one of those two. We don't know which. And it must be a singleton. Though it could be singleton here, blank, and singleton there. That is possible. Huh. Now this is kind of interesting. We have 5-digit rooms here, 5-cell rooms here. If these 4 are in a room, this would be blank, right? Because all 4 of the cells would see that cell. If this is... Okay. So what are the combinations here? Say if this was blue, well, you could have green being here. That's not helpful. This can't be green. If this were green, it would have to be a 4 to be 400 for the 2 and the 4 to add up to 10. So if this were green, this would be 40 something, and that's greater than 37 already. So this cannot be green. Therefore, this is green here, this is blue here, and this is a 4. So this is 4, this is 3, and this is 1 or 2 here. We have 1 or 2 here and 1 or 2 here. Interesting. What else do we have? We have 3 here. It can be a 2-digit number. It could be a 1-digit number. That's fine. These, we don't have any restrictions, really. You could have 434, technically. So 434 plus 431 plus 241 would add to 1106. So 434 which means that's 1 and 1. This is 3. So okay, what happened? Right. So what happens in that scenario? This might be actually the solution path, but I'm trying to figure that out. 431, 241. So this is 3, this is 2. 3 would eliminate 3 here, so that's 4. This can't be 3 or 4, it's 1. So it has to be 12 and 3. So this is 3, this would be 12. Okay. So again, 4 plus 1 plus 1 is 6. 4 plus 3 plus 3 is 10, which carries the 1 over, plus 2 plus 4 plus 4 is 1106. This is 2. We know 1 can't be here. 3 can't be any of these cells. 4 has to be one of these 2. Okay. None of these can be 3. That seems fine. Two cannot be any of these. So 2 is one of these 2. You could have 1 in any of those. 3 has to be one of these 5. Ugh. So that doesn't seem to be a contradiction. So what happens if we go the other route? Okay, so we know this is 430 something. So what happens if we assume that? So then this would be 430 and then 1 or 2. Which would make this, so this would be blue. This would have to be, you cannot have 1 and 1 adding up with 3 to add up to 6. You have to have 1 and 2 adding up with 3 to add up to 6. You can't have 2 and 2 and 1 adding up to 6, so this is guaranteed to be 3. Which means this can't be 3, that's 1. So there's no 1 here. This is 3 or 4. This must be green, and this is 1 and 2. So this is blue in that scenario. This 1 or 2 cannot be any of these 4 digits. So it has to be one of these 2. So these are the same digit here, if that's the case. 2 cannot be any of these digits. This cannot be... So this is at most then. A 3-digit. Can we ever have two 2-digits? We have two 2-digits and a singleton digit, but that doesn't work. So it has to be two 3-digit numbers then, at least. Right? Wait, so in both scenario, no, that's right. Yeah, in the other scenario, this is a 10-digit. Okay. How does that work? This can never be 2 green digits here, but that only gives us... We have 4 other digits left in that region, so that doesn't help. Yeah, let's look at the 3. Okay, so 3-digit plus 2-digit plus 2-digit plus 1-digit doesn't work to add up to 527. Right? Because you'd have to have 4, 4, and 4, right? So that doesn't work. So then this has to be 2 3-digit numbers here. This can't be more than 1. So how do we have 2 3-digit numbers? You can't have 1, 2 because we have 3 digits here. So it would have to be 1, 2, 3. And then this would have to be 1, 2, 3 to have two 3-digit numbers. Okay, that is possible. We know this has to be 1 or 2. to add up to 527. So you could have a two-digit number there. So this is definitely blue. This is definitely blue. The rest of this actually has to be blue because we already have the digits 1 through 4 in that region. So these two are the same digit, right? Because these have to be different to add up to 6 with the 3. So we'd have A here, B here. This is A. This would be B. So this could not be A or B here because it's next to the B and it's... Oh, it could be A. Never mind. It could be A here. Oh, that's not good. 527. Could you add up to 12? Yes, you could have 4, 4, and 4. The ones digit could never add up to, would have to add up to 7, not 17. So either, so this could be 3, could be 2? No, it can't be 2. So 1 and 2 add up to 3, 3. So, and you can't have a carry of more than 1. So therefore, this is not, this could be 2 and 2, 1 and 3, or 1 and 4, or 2 and 3. And you could have like 1 and 1. So with this scenario, this can't be green because that would be too large of a number with 312 at max, at minimum. What happens if we try to have these add up to 2? You'd have to have this as a singleton. This would then be 1 and 1. That would force this to be 2. This would be 1. This would be 2. That would be 1. That's possible so far. This obviously, this would have to be 3 in that scenario. So I don't think, okay, so one thing, okay, so then that kind of works. This can't be 1 or 3. This has to be 2 or 4. This can't be 1. It could be 2, 3, or 4. To add up to 7, though, it would have to, this can never be 4, because that would add up to 9 at minimum, so this would be 2. This would have to be 2, and this would be 3, so that would be 4. So then this would already add up to 16, so this would all be blue. So obviously this, well, we don't know about that. It could be 200 something. We don't have any limitations in that column. So we have 1 there. 4 is one of these two. We don't know which. This can't be 1, 3, or 4. 3 can't be here, so 3 has to be one of these 3 in that scenario. 4 can't be either of these, but 4 could be any of these. So that does work there. So far, not looking good. 2 cannot be any of these. 3 can't be any of these. So we're guaranteed a 3 in one of these two. Huh. This is interesting. Okay. 1 cannot be here, 2 cannot be here, but that doesn't really tell us much. I mean, this is looking valid, and not that many restrictions. And that's without it being, yeah. So, can this ever be 4, I think? I think the answer is no, right? So if we tried this 4, this would be 1. This would have to be 1 and 1. Yeah, so it can't be 4 in that scenario. So this would have to be 2 or 3. So what happens if we try to make this 12 here? Then this would have to be green. This would be 40 something. You'd have 4 here and 4 here. This is obviously not 1, 2, so this would have to be a 1 or 2 here. It is green. These must add up to 4. You'd have 1, 2, 3 remaining in this row. That would force this to be 3 here. So we'd have a guaranteed 1 somewhere in this column. Oh. Yeah, this digit is there. So this is guaranteed to have a 3 in one of these two cells. That's interesting. So can it be 2 and 2? Let's try that. So 2, 2 would force this to be 1 and 1. That would be 1 here. This would be 2. That does work. This can't be 1 or 2. It's 3. Huh. So that kind of does work. These two have to add up to 4. So it could be 2 and 2, or it cannot be 1 here. So no 1 here. Which means this is 2 or 3, which must add up with 1 or 2 to add up to 4. So that does work also. That ain't great. One cannot be any of these digits here, so 1 has to be one of these two. Could be 41 here, that's fine. 2 cannot be any of these digits, so 2 has to be one of these 3. That's fine. Okay. So we're well, that's not true. No, that is true. This is either adding up. This is either adding up to 15 or 16 here. So there's only a 1-digit number possible in the rest of this column. We don't know about this, though. That doesn't help. This could be a 3-digit number as long as this is 1. Um, So obviously these 4 digits could be there, which would force that not to be a digit, which would force all 4 of those to be digits. So this just can't be 1 here. So this is 2, 3, or 4. We're guaranteed, well, we don't know. 2 could be here too. Hmm. What other restrictions do we have? Oh, this is 5 cells. This is 5 cells. Huh. So realistically, probably the 5 cells ones are the ones that are very restrictive enough to help us out. We're guaranteed 2 digits here. We don't have any other information. This is 6 digits, but not very helpful. So we know 2 has to be one of these 3 digits here. This can't be 2. If this were 2, the problem is it would have to have a 1 above it, but then this would be a 3-digit number in some way. So that doesn't work. So either this is 12 here. So 1 has to be one of these 2 digits, right? It has to be a teen. As the 1 has to be in the tens digit. So it's either 1 there or 1 there. Cannot be 1 there because then that would be a 4-digit number at least. So 1 is one of these two. 2 is one of these two. That's interesting. We cannot have 1, 2, 3, 4 in the remaining column. That's interesting. Does that help us any? Not particularly. This is at least 4 out of these, well, exactly 4 out of these 5s must be filled. Exactly 4 out of these 5s must be filled. Same with this, at least exactly 4 out of these 5, exactly 4 out of these 5. 4 out of these 6 have to be filled. This is 6 also. We have 6 here. We have a lot of digits here. This is 6 here. This is 7. This is 7. So this digit cannot be any of these digits here. It has to be one of those 4, which is fine. This digit cannot be any of these digits, so it has to be one of these 2. So we can never have another 2-digit number here, but it could be whatever this digit plus that digit could add up. Oh, interesting. So what happens with this 7 cell? You could have a lot of different digits here, though. Obviously, you can't have... Huh. Oh. There's at most one other digit here. So say this is all blue. Bingo. If this were all blue, and we had 12, this adding up to 16, the problem is, for this region, you could only have 1 digit here. You would have to have 3 digits here. And one of them would have to be a 2-digit number, which with 20-something, 21 at minimum, never adds up to 30. It adds to something greater than 30. So that does not work. So one of these has to be a green, and it has to be 1. So this is guaranteed to be a 1 here. Which means these are not... these cannot be filled out. This has to be then 12 plus 3, so therefore this must be 4. So that's guaranteed to be 4. So this cannot be 4 here. So it could be 12. This can't This could be 3 if this is 1, 2. So this is guaranteed to have a 1 here. You have to have 2 unique digits here. The 4 cannot be here. We are guaranteed a 4 here. So if this were 3 and 4, we are guaranteed 2 digits here, and one of them cannot be 1. So if this were 3, okay, so 1 and 3 are both here. They both see this cell. Well, that could still be 2. Okay. So if this were 3, you'd have a guaranteed 4 here because there's no other place for 4 in this region. This can't be 4. This is 2 or 3. So 4 has to be one of these 2 digits. 3 and 4 only add up with 1 and 2, and we are guaranteed 2 digits here. But we cannot have a 1. It's 2 and 3 at minimum, so that doesn't work. So this must be then 2 and 3 here. 2, 3 plus 4 plus 1 does add up to 10, which is fine then. So this has to be one of these is 4. That means the rest of the column cannot contain digits. And we have to have 2 and 3 here, which means we have to cannot have 4 here, where 4 can't be here because that adds up to 16, whereas the 4, it has to be here. So this is green. This cannot be 41, so this has to be blue. So this must be 1 here as a green. So this is 1. And 2 and 3 have to be some set, but we don't know. It could be 1 here and here. It could be here and here, here or here. And those are the possibilities. So this is 4. 4 is one of these 2. 4 cannot be here. 1 cannot be any of these. So 1 could be here, here, or here. We are guaranteed a 4 here, which means we have to have 3 digits here. Oh, so this is 2, 3, 4, and this is 1. So since this is 1, this is 3, that makes this 2, which makes that 1. So this cannot be blue. Sorry, this cannot be green. It's blue, which makes this green. So again, this has to be 2 sets of 3-digit numbers here. It could be 2 digits there, and then 3. So this is 2 sets of 3-digit numbers. It could be something like that and that. We have 3 digits here. And it's 1, 2, and 3, but we don't know where they are. We have 5 unique digits here. Interesting. It cannot be 3 in a row here. Can't be 4 in a row here. Because it has to add up to 87. Can't be 3 in a row here. So this is guaranteed to be a digit. And we have to have 2 and 1. So 2 and 1 or 2 and 1 to add up to 87. So either way, these are both green. Since these are both green, this can't be green because that would be too big of a number to add up to 142. So this must be green and is 4. 4 then it has to be here or here. This cannot be a digit because it would be that would be 400 to add up to 87, which is not possible. So this must be all green. So this is 1, 2, and 3 here. So we have a 4 and a 4. We don't know what this can't be 4. So 4 in this region has to be one of those 2. So we have a blue-green pair here. This is 1, 2, or 3. This obviously could go 1 through 4. Huh. There's a lot of filled in digits here. We have to have 1 here, 4 here, and 4 here. That's interesting. You could have 2-digit numbers here, though. Huh. This is 1, this is 3. This 1 eliminates 1 here, so this is 3, which forces this. It cannot be 4, 3, 4. But this could be 1 or 2 here, too. No, it cannot. Okay. No, this cannot be the green. If it's these 3 digits and these 3 digits, this must be a 1-2 pair adding up to 3, and plus 3 adds up to 6. But since these are different digits, these must be the same, and therefore does not work that way. So this cannot work because, again, if we try to do that, this would have to be 1-2 pair, both being different digits, but these would have to be different since these are different as 1-2, and these are different as 1-2. These must be the same, and they would be touching each other, which is not allowed. So therefore, this is empty here. This has to be green here, which means this is 4. This is 4, that's 3, and this is 1 or 2. So we have that scenario again. This must be 3 digits and 3 digits because we can't have 3 plus 2-digit numbers twice plus a 1-digit number adding up to 527, right? Because we'd have 4, 4, and 4 because the 1 digits can only add up to 7. They can't add up to 17 because there's only 4 of 1 digits. And the tens digits would have to add up to 12, which would require 4, 4, and 4. But then that would mean the hundreds digit for that 3-digit number could never have a 4. So it has to be 2 3-digit numbers. And again, so it cannot be 1, 2, 3 here. It could be 1, 2, 3 here, but then you would not have another 1, 2, 3 here. You can't have 1, 2, 3 here. Therefore, you're guaranteed this has to be 1, 2, 3, space 1, 2, 3. So this is, we have the digits 1 through, not green, blue. We have the digits 1 and 2 already in the space. Again, it cannot be 4 here, because if this is 4, that requires this to be 1, and then, well, the tens digit here is 40-something. So this must add up to, oh, it has to be 4 and 4, right? 4, 4, and 4, because 3 1-digits numbers can never add up to 17. So this has to be 4, 4, and 4 in the tens digit, and this must add up to 4 for the hundreds digits. So this is 2 or 3 here. So again, let's mark this as A. This is A, and this is B, which forces this to be A. This is B. So these can never have a 4. So this is 1, 2, or 3. 1, 2, or 3. Cannot be 1 or 3 here because there'd be touching. So this has to be 2. Interesting. So that means these digits must add up to 7. Sorry, 7 minus 2, which is 5. So you cannot ever have a 1 there. It's 2 or 3. So it's 2 and 3 as a pair here, which means this cannot be 2 or 3 because we have both 2s or 3s in this region there. So this A has to be 1. So A is 1. B is 2. So this is 2. And 2 and 2 add up to 4 plus the carryover. So this 2 eliminates 2 here, so it's 3. This 3 eliminates 3 here. Or this 3 plus 2 and 2 adds up to 7. 4, 4, 4 adds up to 12. 2 and 2 add up to 4 plus 1 is 5. So this can't be 1 in this region, which means we have to have a 1 here. So this is 1. Okay, 1 could be here. So if we have 4 here, that's 3 and 4. This is 4. 2 eliminates 2 in the rest of the region. This is 1. This could be a teen, or it could be nothing. 2 cannot be any of these, so 2 has to be one of these 3. 3 cannot be any of these, but 3 could be any of these 5. 1 can't be here or here, so 1 is guaranteed to be one of these 2. This can't be 3, 1 something, because that would be greater than 3 or 9. So this is not a digit. This can't be a digit because it sees all of 1 through 4. This sees 2 and 3 and 4. It could be a 1 there, though. 1 cannot be any of these, so in this region, 1 has to be 1 here or here. 1 is one of these digits. Okay. Okay. Let's see. 2 digits. We're guaranteed a 2 here. Obviously, it can't be a 3-digit number here. 3 and 4 cannot be here. 1 can't be here or here. 4 can't be here, but 4 can't be any of these. So 4 has to be one of those 2. That's interesting. We almost are guaranteed we need a 3-digit number here somewhere. Let's see, what else do we have? How many 2-digit numbers do we need here? We need at least 2 2-digit numbers. We have 1 here. I guess this could be a 2-digit and a 2-digit there. Huh. Oh. We have a 4 and a 4 here. That's 8. That means the other digits, 1's digits, must add up to 17. We have 2. We need 2 2-digit numbers. And we can't, could we have 3? We could have 3 2-digit numbers. That's possible. So 1, 2, and 3. We have to have 5 numbers definitely in this column. Because the 1's digits must add up to 17, and the minimum you could have for digits would be 4, 4, 4, 4, and 1. So we have to have 5 numbers. We have guaranteed 1 and 4 numbers here. So this is either a 2-digit number here, or we could have multiple 2-digit numbers here. How does that work? 3. Oh, 1 is one of, well, that doesn't help. 3 is one of these 4. That's not helpful either. So this is done. This is done. This isn't close to done. This isn't close to done. This essentially is done. This is done. 1 can't be any of these digits here. So 1 has to be one of these 3. Okay. Maybe we have to do something with this. Hmm. We know this can't be a 3-digit number. So, and one of the ones has to be here. Ah, so this can't be 2 or 3 here. This can't be 3 here. Right. If we have 3 here, we're guaranteed a 1 here, which means that's a 4. That would have to be 431. So this can't be 3, and this can't be 2 or 3, because if this is 2 or 3, that's guaranteed a 1 there, and this would be 412 or 413. So 2 has to be one of these 2 digits. 3 is one of these 3. Excuse me. Okay. You could technically have all 4 here. You're guaranteed at least one of these is going to be green. How does that work? Obviously, you can't have 3 okay, so if this is... this could be 1 through 4, obviously. Oh, can this ever be 4? If this is 4... yes, it could be that way. If this is 4, then this can never be green, so then you'd have green, 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 green there. Yeah, that could work. Or if this is 1 through... it can't be 3. So again, if it's 3, that has to be green, green here, but it could be 1, 2 here, which would force that to be... So 1 out of 2 or 3 is here, guaranteed. 1 out of 2 or 3 is here, guaranteed. So if this were 2... neither of these could be 2. You could have 24 here. That is possible. None of these could be 4. One of these 2 was 4. If 4 is... oh, that's interesting. If 4 is any of these, then this must be 4, obviously. Does that help? I don't really know. If this is 4, that means 4 has to be here. Which means none of these could be 4. Does that help? I don't really know. Okay, so of the remaining digits, in how many guaranteed have to be green in these columns, or these specific cells? 8 out of these, 8 out of 10 here, and 9 out of 12. 9 out of 12. Interesting. And we're guaranteed We have to have 5 ones digits. We have to have 2 tens digits and 5 ones digits guaranteed in this column. So that means 3 more ones digits and 2 more tens digits. So that's 5 total. We have 1, 2, 3, 4, 5, 6, 7, 8. We have to have 2 2-digit numbers. So 2-digit number space, 2-digit number. You could have a space and another 2-digit number. That could technically work. Let's see what happens if that's the case. So we have 2-digit number space, 2-digit number space, 2-digit number. So that means the rest of this must be a 3-digit number here, or these must be filled out because we have a space here. This could not be a 3-digit number because this can never be 1. So this is not a digit, which means this is a digit, which means this can't be a digit, which means this is a digit. So we have 2 digits here. This digit would have to be the same as that. This can only be a 2-digit number, so this can't be a 2-digit number, which forces all of these to be filled. That seems okay. Huh. 1, 2, 3 here. This is 1 through 4 also. This is 2, 3 as a pair, which eliminates 2 and 3 in that cell there, because they both touch it. 1 through 4, 1 through 4, huh. Not too restrictive, unfortunately. This digit is the same as that digit there, guaranteed. So this is A, which makes that A. So neither of these are A, so A has to be one of those two. But that seems fine. This digit cannot be the same as any of these three, so it would have to be the same as that. So this digit and this digit are the same. So we'll mark it as Z. I don't know if we have very many restrictions there. This can't be 3, because if this were 3, that would be 30-something plus 4, which adds up to greater than 34. So this is 20, this is 3, so this can't be 3 here. This can't be 2 here in that case. But that doesn't seem to preclude very much. We know so this is 1, 3, or 4. So, not too restrictive. Okay, let's not go down the rest of this path. What about if we try to get... a 2-digit number, 2-digit number, and a 1-digit number. So say this was... There's so many different possibilities, though, for that. Oh, this digit has to be a digit. So, and it cannot be any of these, so it must be this one no matter what anyway. So this is always going to be Z. That's always going to be Z. Because there's no other place for it in this region. This one could be the same as either of those two. If there's a digit. We don't know if there's one there. Okay, so what happens if this is a 4? That's interesting. So if this is 4, that's 4. This obviously cannot be a digit here. So therefore, it's a digit here and a digit here. Wait, it's the other way around. It can't be a digit here. So it can't be a digit here, which forces digits to be here. That seems okay. This is 40 something. So then we have no digit here, no digit here. That requires this to be a 2-digit number. Interesting. No 4 here. We have 1, 2, or 3 here. This is 1, 2, or 3 here. 1, 2, or 3 here. It seems okay. This could be a 2. Oh, these are all filled out because this is empty. So we don't know about this. This cannot be 1. And therefore it would have to be blue and blue. This would have So this, if this is a 4, then that it guarantees that this has to be this scenario. So then this would be 2 and this would be 3. This would not be a digit. This can't be 2 or 3. It would be 1. That means this could not be 1 here. No 1 here. This cannot be 1. So this is 1 through 4, but no 3 here, no 1 there. So the 10s must add up to 70 something, because the 1s definitely add up to, oh. That's not going to work. So this cannot be 4. This doesn't work because the 1's digits adds up to then at most 4 plus 4 plus 3 plus 1 plus 4, which is 16. And it has to add up to 17. So that doesn't work. So this, therefore, because of that, we know this can't be 4. Which means in that region, 4 has to be here. So this is 4. Okay. So can this be two 2-digit numbers and then a singleton? The answer now, well, it could be two-digit numbers if these are the 2-digit numbers. So that's possible. This can't be 4, it's 1, 2, or 3. So it's the same as that Z. This can never be 3, because if this is 3, that would be 30-something, right? So 3 can never be here, which means 3 has to be one of these digits here. So this can never be 3. That doesn't really tell us much. 4 is one of these 4 digits. Sorry, one of these 4 cells. You could have a 2-digit number here, and that would be 40-something, and then 30-something could work. So one thing, okay, so what happens if this is green? We have a 2-digit number here, a 2-digit number here, and you would have to have a 2-digit number there to add up to 87, because this is at most 30 plus 20 something, which would be 50 something. Can this ever be a digit? If this is a digit, that means all of these, one of these cannot be a digit. So all of these would have to be a digit. One of these would be a digit here. So if this is a digit here, so say this was a digit here and the digit, that forces a digit there. That means one of these cannot be a digit. So we'd have digit, digit here, digit to here. Hmm. Interesting. Okay. So, if, well, that's not true. We could have 2 and 3. So can you ever have 2-digit, 1, and then 2 digits here? I think the answer is no. So if you have a 2-digit number, a 1-digit number, and a 2-digit number in any order, the ones must be either 2 and 3 to add up to 5. It has to be 2 and 3 adding up to 5, because then to add up to 17 total, you need another digit here. So the ones digit would have to be 1, and then you'd have a max of 4 for the other tens digit, which is 50 something. But you only have a carry of 1, so that would make 60 something as the maximum amount. So you can never have two-digit numbers in this column with a singleton digit. It has to be 3 2-digit numbers. So this is 2-digit number, 2-digit number, and 2-digit number. That in this region, we already have the one box that it's not filled out. So that means these have to be filled out. This is 1, 2, or 3 here. Okay. This cannot be a digit, because then this would be greater than 191, because it would be 200 something. So then this must be a digit here. This is not a digit, and this is a digit here, which forces this to be 20, and this is 3. That means this can't be 2. This is 1 or 3, which means this can't be 2. That's 1 or 3. No 3s in either of these cells. This can't be a digit, because that would be 200 and something. So that leaves the remaining digits in this region as these. Okay. That was pretty hairy, but okay. That kind of works. This is a singleton digit. Well, we don't know what this is. This can't be 2 or 3. It's 1 or 4. So this has to be 1 through 4, and this is 1 through 4. This digit, again, A, cannot be any of these digits, so it has to be A there. So if this is 1, that wouldn't work. If this is 1, the 1's digits then would be 4, 4, 3, 1, 4 at maximum, which adds up to only 16. So this cannot be 1. It's 4, which means the rest of the region cannot have a 4. Also, this cannot be 4 here, because it's consecutive. It's touching an A, which has to be the same as that cell. So this can never be 1 here. This has to be a 2, 3 pair. So this is the same, right? You have 4, 4, and 4. That's 12. These must add up to 5. You can't have 1 here, because this can't be 4, because it touches the 4 there. So it's 2 or 3, right? This can't be 3. It's 1, 2, or 4 because it's touching 3. 4 cannot be here. 1 can't be here, so 1 in this region has to be one of these two. 4 can't be here, so 4 in this region has to be one of those 3. So these are separate digits. So this is A, this has to be B. And B touches both of these, so this can't be B. These can't be B, this has to be B here. So this is B and cannot be 1. It's 2 or 3. This is a 2, 3, 2, 3 pair then, B and A. So A is one of these two. That means in this region, Z has to be here. B cannot be either of these, so this must be the same as this. So this is C. Okay. So C, okay, can this be 4? If this is 4, this has to be a 1, 2 pair to add up to 7. So yes, I think. So this would be 1, 2, this would be 3, and this would be 2. Okay. Yeah, so this could be 4. Can it be 1? 1, 3, and... so C and Z are different. So this adds up to, at most, 5. And it cannot be 5. It includes a 1. So this can't be 1 because A and B must add up to 5. And you can't have 4 here because of the 4 touching this cell, and this cell must be the same. This digit must be the same as that digit. So 1 is guaranteed to be in these tens digits. So that means it's 1 and 3 at most. But 1 and 3 would have to add up with another 3 to add up to 7. So it cannot be 1 and 3. Because this can't be 3 because it's touching a 3. So therefore it must be 1 and 2, and this must be 4. So Z's are 1. C's are 2. Which means B's have to be 3's. And A's have to be 2. And then this adds up to... so 4, 4, 1 and 2 is 30. Plus 4 plus the carryover 1 would be 80. So this is 4, which means this is a 1, 3 pair here. We don't know which. This is 2. Okay, so that's all done. Woo, that's pretty crazy. 24 something here. We don't care about that. This is 25, which means the remaining digits must add up to 9, which could be a variety of things. Okay, we are guaranteed a 2 here. But it cannot be a 3-digit number here because that would be greater than 142. But you could have a space here. It could be 21 also. That's fine. 4 and 3 cannot be here. This can't be 1, but this can't be 2, but you could have a 1 here, you could have a 2 here. Okay. We have 309. 4 is here. This can't be 4. That doesn't help. Okay. We have a 2 here, so we have 3 digits in 5 spaces here. That doesn't... it's not very restrictive, so we don't have very much information there. Can you have 2 digits numbers only here? I think the answer is no, right? So 2 digits, 2 digits, 2 digits. That means 4 2-digit numbers, which would mean the ones digits would have to add, the tens digits can at most add up to 1 and 6. 16, right? 4 plus 4 plus 4 plus 4. And that means the ones digits would be at most 3 times 4, which is 12. And that does not add up to 191. So we need a 3-digit number here with the 1 as the beginning number. Okay. Huh. Interesting. That doesn't help much. Oh, this is never a 2-digit number now for the rest. Well, yeah, this cannot be 1. 14. 14 plus 21 is 35, which is already too big. So this is blue. You can never have a 2-digit number in any of these spaces then. But these could both be blue, so that's not helpful. We add up to 9. Hold up. We add up to 9. That means we have to have 3 1-digit numbers here. We have to have 3 1-digit numbers here. So it's either green, 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 or green, green, green. Interesting. So one of these is blue, one of these is green. One of these is blue, one of these is green, one of these is blue, one of these is green. So one is one color, and the other one is a different color. We don't know which is which. And it must add up to 9. That's the reason why we know we have to have 3 1-digit numbers. You can't have a 2-digit number, because a 2-digit number would add up to 35 at least. And to add up to, we have to get to 4 and the 1's digit. We already have 5, which means we have to have 9 total. So there's 1 digit between these. There's 1 digit between these. Okay. There's 1 digit between these two. Okay. So this is not a digit here. If this is a digit here, that means none of these can be that digit, which means that would have to be a digit. That seems fine. If there's a digit here, that means none of this can be a digit, but it could be 2, right? Or it could be this digit here. I'm not sure which. So the remaining, so we've essentially finished that clue. We haven't done this one yet. This one we haven't even touched. This one we haven't really touched. This one we haven't really touched. Okay. This is done, and this is done. Which one do I tack then? This has to be at least a 2. Can we have 2-digit numbers? I guess. Yeah, we could have multiple 2-digit numbers there. That's not helpful. This digit must be... So if it's a digit, it would have to be here. So it has to be different from this one, whichever, if it's here. Oh, it doesn't have to be alternating. It could be 1 here, 1 here, 1 here. Or 1 here, 1 here. Okay, so this is not correct. We do know that we have to have 3 1-digit numbers here. Okay. Not too helpful. Never mind. We're not completely done there. And it wasn't even completely done. It was just maybe we have something there. Hmm. Hmm. Three is one of these 4 digits. Not too helpful. Oh, this 3 eliminates 3 here, so this is 1, that's 3. I was wondering, I'm like, how do you disambiguate this one? And it's like, oh, this is a 3, which makes that 1. So there we go. This is probably going to be disambiguated by the 191 clue here. Hmm. If there's a digit here, it also has to be here. Okay. Oh, this is interesting. So, okay. If this is a 3-digit number here, huh. So say we have all green here. That means this can't be a number, or this can't be, yeah, this can't be a digit. That can't be a digit. You would have to have 100 and something here. We do know we have to have a 3-digit number in one of these cells. Because, again, 4 2-digit numbers does not add up to 191. So this would be 1 then. You could have a 2-digit number here. And a 1-digit number there. This is always going to have to add up to at least 11. Can it ever add up to 21? And the answer there is no. Right? If it adds up to 21, you'd have to have, well, a lot of 1 digits, a single digits, and that's not possible, right? You have to have a 3-digit number. So let's just make it at the very end. We have a 3-digit, blank, 1-digit, blank, 1-digit, and that's just 2. You have only 4 1-digits adding up to that. So it has to add up to 11. Which means the 2-digit numbers must add up to 18. But you could have another 2-digit number here. We are guaranteed the 1 in the hundreds place for the 3-digit number. Huh. Okay. Huh. Um... If this is a 1, so that's interesting. If this is 1, that means this can't be 1, so this is 1 here. That would mean this cannot be 2 and 3, because that would add up to greater than 142. So then this would have to be 3 here. That seems fine. 4 is one of these two. It cannot be 4 here. It can't be 3 here. So then that would force... Interesting. That would okay, so the only way this is not 1 is if this is, well, so if this is not 1, I guess you could have 1 there. Oh, you could also have 1 there. Dang it. Okay, I forgot about that. One has to be either here or here. That's interesting. So if one is here, one cannot be here, and it has to be one of these two. If one is here, it can't be any of those, but it could be any of those four. That ain't great. 3 could be any of these. Just like 3 could be any of those 4. We have to have a 3-digit number. Okay. You could have a 3-digit number here. You have to have at least one 3-digit number in this column to add up to 309. And it cannot start with a 4 or a 3. We need a 3-digit number in this row. We cannot have 3-digit numbers in these columns. We have 6 here, 6 here. So we are guaranteed 2 out of these 3 digits are filled. At least. So if we try to have a 3-digit number here, let's see what happens. Then this would obviously not be. This has to be, so all of these are filled. This cannot be a 3-digit number here, so this is blue. This is not a 3-digit number, so then this would be blue and blue there. You cannot have a 3-digit number here. Therefore, this must be a 3-digit number here. But that's never going to add up. Because you'd have a space here. This would be a 2-digit number at most. This would have to be 140-something at most. Plus 40-something is never going to add up to 309. So that's not going to work. So you cannot have 3 greens there. What about if we try to have this 3 greens? So 3 greens there. This is then blue and blue, and you'd have to have that. This would be green. This would be green. Oh, that's interesting. So, you can have a 3-digit number here, but it could only start with 1, which means you're guaranteed you have to have a 3-digit number in this space, right? If you don't have a 3-digit number here, again, this is at most 140-something, with which one 2-digit number is never going to add up to 309, starting with 4. So this has to be a 3-digit number, either this one or this one. So these have to be 2-digit numbers here. If you have 1 here, you could have a 1 here, but does that add up? So say we had 1 here and another 3-digit number here. This can't be a digit. This can't be a digit. So you have 143 at most for both of them, which is 286 plus 4 and 3 is never going to get to 309. Okay, so there you go. So this cannot be the blue here then. So this has to be blue here. Or sorry, green, green, green here. And I think this has to be 2, right? 143 plus another 143 plus 4 and 3 is never going to add up to 309. It's 286 plus 7, which is 293. So this has to be a 2, which means we have to have 2 2-digit numbers, right? To add up to 309. If we only have 2, okay, so the 1's digits could be 3, 4, and we have a 2-digit number here. So this has to be 1, 2, 3. This cannot be a digit, so this is nothing. So this has to be 1 here. 1 cannot be either of these, so this must be a 3, 4 pair here. Therefore, in this box, we have to have a 1 in one of those 3 cells, or sorry, this region. This can't be 4 because one of these two has to be 4 in this region, so this is 3, which makes this 4. 3 cannot be any of these cells, so where's 3 in this region? It has to be here. So this is 3. This cannot be 4 because it's next to a 4. So we have this is region, this is region, this is digit. So we have 4, this is 3, and this is not a digit. Okay. So we have 234 here. The ones digit has to add up to either 9 or 19. The problem with having and the tens digit, the problem is we have to get to either 9 or 10. Well, with 9, we need 2 other digits at least, right? 4 and 2 at minimum. So this has to be two 1-digit numbers, or sorry, two 2-digit numbers. And if this cannot be a 3-digit number because that's already 234 is greater than plus 100 is greater than 309. So it has to be two 2-digit numbers, which has to be then 2-digit number here, 2-digit number here, which means this is not a digit, so it's not 1. So this must be 41. So then the ones digits must add up to 9. So that's 3 plus 1 plus 4 plus 1 adds up to 9. So 1 cannot be either of these digits. 1 in this region has to be here. So this is 1. The tens digits must add up to 10. So we have 3, 4, and this must be 3. So that's 3. Right, so 3, 4, and 3 adds up to 10. Plus 2, so they'll carry the 1 over, plus 2 is 3. 1 can't be here now because of 1 in the region. We have to have 2. 2 cannot be here. 2 has to be one of these digits here. Okay, so this is not a digit here. This is 234. So 1 has to be one of these 2. This is a 3. So as a 3-digit number, again, you cannot have this 3-digit number and then a 2-digit number here because 2 of these are at least going to be green. Could be all 3 actually. 3 and 4 cannot be here, so we have to have 3 and 4 in this region be here. So 3 and 4 have to be in this region here. Interesting. What else do we have? So if we have a 3-digit number going this way, I guess it could be 1, 2, and 3 technically. And then this would be 3, 4 as a pair there. Huh. 2 cannot be here, so 2 is one of these 4. 1 can be anywhere. Oh, 1 cannot be here because it's touching 1. So 1 in this region has to be one of these 4, so this can never be 1. So this is 2, 3, or 4 here, or nothing. So 309's done. All of these in this column are done. We don't have this yet. This cannot be all 3 digits here. if we have all 3 digits here, that means this would be a 4-digit number, which is greater than 191, obviously. So only 2 out of these can be green digits. So therefore, these have to be digits here. So this is definitely 1 or 2. And this is definitely 2, 3, or 4. This is not a digit. Oh, well, there we go. We don't have a digit here. We have to have 3 singletons here. So this must be green, blue, green, blue, and green. Okay. This cannot be 2 because of the 2 in one of these 2 cells. So this is 1 through 4. Okay. This could be many things. 1 through 4. 1 is one of these 2. 4 has to be one of these 4. That's not that helpful. You cannot have a digit here, because then if there was a digit here, it would be a 3-digit number. So this is blue. This has to be the 1's digit of something. Two, 3, 4. This is 1 or 2. So this cannot be a 3-digit number 1, 2, 3. If this is a 3-digit number, this has to be a 1 because it can't be 2, 3, or 4, and therefore this would be greater than 191. So this cannot be a 3-digit number. Therefore, both of these cannot be green. So that means one of these is green, one of these is blue, so that must be green there. So for a 3-digit number, again, you can't have 3 digits here. It has to be either 3 digits here or 3 digits here. So can't be here. It's either 3 digits here or 3 digits here. So this is green either way. If this is... Say... Okay, so say this was a 3-digit number here. That would mean this is blue, this is blue. This would have to be green and would have to be a 1. And then these 3 digits would have to add up to 11. But that's not possible with 3, 3, and 4. That would be 10 at most. So that doesn't work. So this cannot be 3 digits here. It must be 3 digits here. Since this is 3 digits here, this cannot be a digit, because this is a 2-digit number already here. This can't be... This is a singleton digit. This cannot be 4, so it's 2 or 3. This is not a digit here, which means this is not a 1. You're guaranteed a 4 here. 3, 3, and so we have to have a singleton 1 in this row, because otherwise it's never going to add up to 11. It can never add up to 1 already, because this is 3 plus 3 and 1 at most. Interesting. So we have 2 digits here. These are all digits. This has to be a 1, because it has to be 100 and something. So this cannot be 1 here. So we know, okay, so we can just remove these possibilities for the in the corners. This has to be 1 through 4. No 1 here because of 1 in that region. This can't be 1 because it's touching 1 there, so this is 1. We have to have, so this has to be a 4. The tens digits must add up to 9 with a 1 carryover, so it must be 4 and 4, which means this cannot be 4. This cannot be 4 in either of these spaces, so 4 in that region must be here. This must be a 2-3 pair. This can't be 1 or 4, it's 2 or 3. So to add up to 11, you have to have 3, 3. Can you ever have a 1? The answer is no, because none of the 1 digits can be 4s. So it has to be 3, 3, 3, and 2. So this is 3. This is 2 or 3. Right? 3, 3, 3 is 9 plus 2 is 11. So then this is 1 here. We have a 2, 3 pair in this region, so this can't be 2 or 3. It's 1. This is 2 or 3 here. So these... Okay, so where do these match up? We have... I'm going to make this A, this B, so this is A. This can't be B, so this is A, which makes that B. B cannot be here because it would be touching this, so B has to be one of these two. 4 has to be in this region, cannot be here because of 4 in this cell. Can't be here because of 4 in this cell, so 4 has to be here, which means this is B. So this can't be a cell here because we have 1 through 4 already. We have 2 or 3 here. 4 cannot be either of these, so 4 in this region has to be one of these two. 4 cannot be here, but it could be any... It can't be here. It's in this region, it must be here. One of these cells. If this were... Can this ever be 4? The answer is no. Oh, we have a 2-digit number here. But any 2-digit number here... You cannot have a 2 here, because if we had a 2 here... We can't have another digit. It can't be 1 or 3. This would be 20-something or 40-something. Plus another 20 adds up to 40-something here, which is greater than 37. So this cannot be a digit. So it's not 2, which means this must be 2 here. And is a digit. 4 then has to be one of these two. Can this ever be 4? I think the answer to that is no. Right? If this is... How many ones digits will we have if that's the case, right? We can only have one more ones digit. So 4 plus 3 plus 4 plus 1 only adds up to 12. So it has to add up to 7. And then 4 plus 2 plus 1 plus 1 adds up to 8 already. So this can never be 4. Which means 4 in this region has to be one of these 3 cells. Well, they all see the 4 here. So this can't be 4 here. So where's the 4 in this region? It must be there. So this is green, this is blue. These add up to 9. 4 could be there. Okay. This is 4. 3 eliminates 3 as a possibility here, so this can't be 3. Oh, these can't be 3 all the way here. Because of 3, I should have gotten that already. So therefore, in this region, 3 has to be here. So this is 3. This is not a digit, because it can't be 1, 2, 3, or 4. 3 is one of these two. So we need a 100 something in here. Okay. 100 something cannot be here. So this can't be a 3-digit number. So 1 has to be one of these 3. Right? We need a 3-digit number. You can't have 4 2-digit numbers. Well, can you? Well, not with 24 anymore. Well, not necessarily. Okay, maybe that could be 4 2-digit numbers. 142. Yeah, that could be 2 4-digit numbers. Okay, never mind. 3 is one of those two. 2 is one of those two. This is 2, so this is 1 or 3. There's no restrictions there. So this is either 32, and then we have 12 and 1. That's possible. Can this ever be 3 here? I think the answer is no, right? If this were 3, you'd have the 1's digits adding up. Oh, it could be. So, can this be 1 as a digit? Yeah, 32, 1, 1, and 3. So all of them kind of work. Right, if this is 12, you have 1 here, 13, plus 23, which would be 36 plus 1. Interesting. Huh. Okay. So 12 works with 23. 13 does not work. If you have 13 here, so 13 plus 1 is 14, plus 1 at minimum is 15, plus 23 at minimum is 38. So this cannot be a 3, which means we guarantee have a 3 here. So this is 3. Can you have 4 2-digit numbers here? The answer is probably yes. So if this is not a digit, you have 1, 1, 32 plus 3. If you have a 2 here, that's 1, 12. So that's 13. Plus 23, which is 36 plus 1 there. Okay, not helpful. So this could be 1 or 2 here. If this is 2, that would force all of these to be 2, or none of those to be 2, which means 2 would have to be here. But it could be, because there's no restrictions there. You have A and B, A and B. B cannot be any of these. So B has to be one of those 3, but that doesn't help. So do we look at the 4 2-digit numbers? Can it be a 3-digit number here? I guess? Well, 1 can't be here. We're guaranteed a 2 here. Okay, so what does this add up to? We are guaranteed a 2 here, and it's the 1's digit, guaranteed. So we have 2 as a 1's digit, 2 as a 1's digit, and 4. Can you ever... so can we have... we can have... how many more 1's digits can we have? We could have 1, 2, 3, 4, and 5. But that adds up to at most 20. And with the 4, 2, 2, it's really 16. So this must add up to 12. So we have one more ones digit left. And it must add up to 12. So if we have a 3-digit number, it would have to be plus a 12, right? Say we had a 3-digit number. It'd be 120. It doesn't work. You can't have a 3-digit number. Okay, well, there we go. So the ones digits adds up to 12, which means the tens digits add up to 13. Can you have that with not 4 2-digit numbers? So 3 2-digit numbers. The answer is no, because 4 times 3 is at most 12. So you have to have 4 2-digit numbers in this row. So this is 42, because otherwise you're not going to have another 4. So this is not a digit. If we have 2 here, this cannot make 2 2-digit numbers here. So 2 has to be here. So this is 2. This is not a digit. And this must be a digit here. So this is not a digit here, and these two are digits here. Okay. So then we have 4 2 2, and then that's 8, plus another 4 adds up to 12. So that's 4. That means these digits must add up to 13, because the 1 carries over. 13 minus 6 is 7. And this can't be 4, so this must be 3 here and 4 here, which eliminates 4 in the rest of this region. 2 can no longer be here, here, or here, so 2 in this region has to be here. So now we have 1, 2. This is 12, so this cannot be 30-something, because 12 plus 30-something is 40-something, which is greater than the sum. So the A's are 2. The A's are 2, and the B's are 3. So these are 3. And then we have 1, 12, 23. That's 36, so this must be 1 here, which means we need a 3 left in this region. Well, 3 can't be here because of 3 in this cell here, so this must be 3 here. So this is 3. This is 1 to add up to 34 here, or for the ones digit, it must be 14. We have 14 minus 6, which means this must be 8, so this is 4 and 4, which eliminates 4 in the regions there. So this is 1, which eliminates 1 here, so this must be 1 here. So that's green. This is not a digit. We have 1 and 2 left in this region. So 1 or 2. We have 3 left in... Okay. So where are the possible ones? So, okay, in this region, we have 1, 2, 3 left. So 1 and 2 could be here. And this is 1, 2, or 3, but this can't be 2 or 3. So we know 3 in this region has to be here. So that's done. 3 cannot be here in this region, can't be here, so 3 is one of these two. We need 1 and 2 in this region. This can't be 2 because of 2 in this cell here. We have 1, 2, and 3 in this region. So again, this can't be 3. This can't be 3. We have guaranteed 2 in one of... This can't be 2 because of 2 in that cell. We have guaranteed 2 in one of these two cells because this can't be 2 because of that 2. So this can never be 2 here because it would be touching one of those. So 2 has to be one of these 2 digits here. Okay. This can't be 2 because of 2 there. So in this region, we need to have the 2 there. So this is 2, which means this can't be 2. Which means 2 has to be here in this region. Um, 3 then has to be this digit because there's no other place for it in that region. Huh. 1 is one of these 3 digits. It could be 1, okay. It could be 1 and 1 here. Oh boy. If this is 1, that means this is 1 and 1 here. 2 can be either of these. We don't have very many restrictions here. Huh. Oh, this can't be 1 because of 1 here. There we go. So this is not a digit. Okay, so that forces this to be 1 here. So this is 1, which eliminates 1 being these 2 digits, so that's 1 there. So this can't be 1, this can't be 1. So we have to have 1 here and 2 here. So then this is 1, and this is 1. This is not a digit, and this is not a digit, and this is a digit. So this is 2, and that's 1 there. And I think that's the solution. So in every region, do we have 1 through 4? Only once. Yes here. 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 1 through 4. 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 1 through 4 here. 1 through 4 here. 1 through 4 here, 1 through 4 here, 1 through 4 here, 1 through 4 here, I think we already did this, 1 through 4 here, 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 1 through 4 here. Are any digits touching each other? So ones, nothing touching, not even diagonally. 2s, nothing touching, not even diagonally. 3s, nothing touching, diagonally. 4s, they're not touching, these aren't touching, these aren't touching, these aren't touching, these aren't touching. So none of them are touching. So then, the sums. 431, let's just actually, well, 1, 2, and 3 add up to 6, so that's fine. 3, 3, and 4 add up to 10, so that 0 is working. 1 carries over, plus 2, plus 4, plus 4 is 11, so 1106 is satisfied. 2, 2, and 3 add up to 7. 4, 4, and 4 add up to 12, so the 1 carries over, with the 2 and 2 add up to 527. 4, 2, 2, and 4 add up to 12. 1 carries over. So 1 plus 2 plus 4 plus 4 is 11 plus 3 is 14. So 142 is satisfied. 1, 4, 1, 4, 4. That's 9 plus 5 is 14. 1 carries over plus the 20 is 34. 3, 3, 3, and 2 add up to 11. 1 carries over, plus 4 and 4 is 9, and then when 1 in the hundreds digits is 191. So it's satisfied there. 1 plus 2 plus 1 plus 3 is 7. 2 and 1 add up to 3, so 37 satisfied there. 4, 1, 1, and 3 adds up to 9. 3, 3, and 4 adds up to 10, and then 1 carries over, plus 2 is 3, so that's 309, so that satisfies there. 1 plus 2 plus 3 is 6, plus the 10's digit 10 is 10, so that's 16. 3 plus 2 plus 4 plus 1 is 10, plus the 1 carries over, plus the 2 is 30, and then 2 plus 4 plus 3 plus 4 plus 4, so 4 times 3 is 12, plus 5 is 17. 1 carries over, plus 4 plus 1 plus 2 is 7 plus 1 is 87. And so this is the solution. Whew, that was a doozy. Very, very cool, actually. A very nice puzzle set. Some of the interesting logic behind what can and can't be in certain regions. Yeah, it definitely was very hard, but I think very satisfying overall. Um, Either way, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.